Sanya Bansal express a warm and respectful welcome to the 14th International Conference, Confluence 2024, Cloud Computing, Data Science and Engineering, organized by Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated towards its responsibility of imparting its students with strong foundation and a platform for the empirical inquisition. With this agenda, Conference 2024 intends to bring together professionals, academicians, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovations, share research results, and new directions in the field of next generation technologies. It's a great privilege and honor to have amongst us Professor Dr. Bhuvan Unhulkar. Dr. Bhuvan Unhulkar is an accomplished IT professional and professor of IT at the University of South Florida, Sarasota Manati lead faculty. He is also founding consultant at Method Science and a co-founder director at Clarify. He has mastery in business analysis and requirements modeling, software engineering, big data strategies, agile processes, mobile business, and green IT. His domain experience is banking, financial, insurance, government, and telecommunications. Bhuvan is a thought leader and a prolific author of 20 books, including Big Data Strategies for Agile Businesses and The Art of Agile Practice, Taylor and Francis, CRC Press, USA. Recent Qatar executive reports, Boston, USA, include Psychology of Agile, Business Transformation, Collaborative Business, and Enterprise Agility and Agile in Practice, a Composite Approach. He is a winner of the Computer World Object Developer Award 1995, Consensus IT Professional Award 2006, and IT Writer Award 2010. He has a doctorate in the area of object orientation from the University of Technology, Sydney in 1997. One is Fellow of the Australian Computer Society, IEEE, Senior Member Professional Scrum Master, Life Member of Society of India and Baroda Management Association, Member of SDPS, Past President of Rotary, Sarasota, Sunrise, Florida, and Sun Eyes, Sydney, Paul Harris Fellow, Discovery Volunteer at NSW Parks and Wildlife, and a previous TIE mentor. Now, I request Professor Dr. Bhuvan Unhulkar to kindly address the gathering with his please words of wisdom. Please, sir.
Thank you. Good morning to everyone. Namaste to everyone. Good evening from here in Florida. And good day to my dear friend Keith Sheringham, who I can see. That's a good test of whether the mic is working or not from my end. Welcome also to all the students. MET is a known place to me, and I have been there multiple times. But right now, I'm not able to travel, so I'm going to share my thoughts with all of you sitting here in Florida. So let me see if I can share my screen. I think that should work. So let me know if you can, or okay, let me know if you cannot see. I think you can see my screen. I'm going to minimize this on the right, so I won't be able to see myself or you for a short while. Yes, yeah. If something is going wrong, don't hesitate to unmute and let me know. But in the meantime, let me take you through some of my thoughts. It's a beautiful 11 o'clock evening over here, and it's nice and cold, just as nice and cold in Delhi. So I'm going to speak for about 20 odd minutes, 20 to 25 minutes, and then leave a few minutes for some question and answers. So this is what I want to do. I was given a great introduction, although that is a slightly older profile. I had sent a updated one to Garima ma'am and Richa ma'am. Anyway, the idea is to basically share with you what I'm doing and see if there is a opportunity to collaborate. A little revision on what we really mean by artificial intelligence, and then a bit more discussion, slightly more detailed discussion on leadership, as that is our agenda. I will also mention business analysis, because I think business analysis and leadership have a fair amount of overlap. And this is precisely analysis and not analytics. We'll see how it goes. I just thought I will go through the memory lane very fast, but just to remind you how well I have been connected with Amity. So this was in 2020, 29th of January, and then COVID struck, which all of us know. But I was really delighted at that time. Professor Bansal was around, and I was made the one of the many honorary professors during that conference. Then I talked about environment intelligence once again 1 year later in January 21, which was online. And oh, I'm very proud of this certificate. And then again on artificial intelligence and business optimization or business process optimization to be precise. And this was from Sydney. As you heard, there is a lot of Australia in my resume as much as India. And my very dear friend and co-author Keith Sheringham is sitting right there. So this was presented from Australia. I was there on my sabbatical. And this is just a revision of my profile, but the fun part is that I've written a few more books after that last version of the resume was written. And there are many postdoc fellows that I am supervising right now, primarily from India, but there are a few from Australia as well. And you can see how proud I am of my honorary membership of MET. It is my practice to simply share these books, but there is absolutely no plan to sell any of these books. I had brought some of them and, in fact, given them to MET. So I hope that they are sitting there somewhere in the library. One is The Art of Agile Practice. Another is Software Engineering with UML. And this was the one that I had written with another professor. He came from Sophia University in Japan, Tad Gonsalves, and we wrote on a book that deals with artificial intelligence for business or for business optimization, which I believe will be the focus of most of the management students or master's students. Here are a few more books that I have worked on. This is what I had used last year to present on Green IT, or year before. And the great author of this book, the lead author, is sitting right with you, which is Keith Sheringham. And yeah, a few more arts of work. This was the very first, as you know, as you were not there, but as some of you might know, India's IT sector became world known during the Y2K chaos. Still trying to submit the book, but just like you students have your excuses, we professors have our excuses of why we have delayed our submissions. If you are interested in any of these areas to collaborate, and I invite students, faculty, I am already collaborating with some of your faculty and some students, but you're welcome to reach out to me. So now let's have a bit of a chat on today's topic, which is really exploring digital leadership and why it is important, how it is different from a normal leadership, what should a good leader look for, and that's what I'm planning to share with you. And how is a digital leadership different to a traditional leadership? And this is an ongoing research project that I have undertaken, very formal with IRB clearance and so on. And I have interviewed 40 plus digital leaders from around the world. And even though I'm yet to analyze their interviews, I find that digital leadership does not miss out on anything that we discuss in leadership. So it is everything that a leader should have and some more. And the additional bit is that the digital leader is focused on data driven initiatives which will incorporate data driven decision making. A leader, a digital leader, is focused on business agility. Agile as a software development method has long passed its aha experience, its aha impact. Everyone in projects, including people in Bangalore or people in Philippines or people in New York, are using Agile and primarily Scrum. But the agile that I'm referring to is the agility of decision making. And a digital leader who is leading a digital organization has to be fully focused on the agile aspect, the dynamic aspect of decision making. And if any one of you are looking for a career that will last 10 to 15 years, because all other careers are going to change in 5 years, then cybersecurity and privacy are the key aspects of a digital leader's concern. And that's what I am discovering. I'm going to take you a bit more into it, such as what should a digital leader keep in mind when she or he is put in that position. Okay, take us beyond where we are. Show us how we can utilize big data, machine learning, artificial intelligence. Then that particular strategy making exercise, decision making initiative is going to consider opportunities that are external, optimization, improvement of processes that is primarily internal, risk and compliance. If there is one big advantage that digital technology provides to a leader, is the ability to comply with the myriad rules and regulations. As digital complexity grows, so also the policies, procedures, rules, regulations that governments and other auditing bodies, other compliance bodies impose is just phenomenal. I have a very dear friend here in Florida who owns a company called Risk Watch. And what it does is it helps businesses comply with the requirements of the government. And of course, in that process, manage the risk. So risk and compliance is big. GRC, you must have heard, governance, risk, and compliance. And really, environment and CSR, corporate social responsibilities, are never going to go away, but they take a further significance in the digital world. Although I have put these words in front of you, each of these, like agility and business analysis, are big words and they require discussion on their own. But in this keynote, I would like you to remember that business analysis is a specific profession with its own uh, certifications, with its own frameworks, driven by IIBA, International Institute of Business Analysis. And business analysis so far has been focused on analysis, as its name suggests. But in your case, when you dip into digital leadership, there is also a need for synthesis, looking at the whole business holistically. And this is my output, my product, my research, which brings agile and planned philosophies together. And that is one of the key requirements of a digital leader, that they are able to balance agility, that is pure agility as presented in year 2000 by the Agile Manifesto, with the planning, strategies, auditing, compliance, documentation. You must have noticed, if you are traveling by air or by train or even by bus in India or overseas, that a airline is also able to offer you car rental, hotel rentals or hotel rooms, travel insurance, medical insurance, so many things. This is possible in the digital world, and which means Air India, which is not in the business of insurance, is offering you travel insurance through collaboration, automated collaboration, electronic collaboration, cloud-based collaboration with the insurance company. And that is the basis of fuzzy organizational boundaries. Most organizations are fuzzy because they are dealing with other organizations, unlike a physical wall around a company. Way back in 1982 to 1986, 4 years, I worked for Telco in Pune. Telco is Tata Engineering, which is now Tata Motors. And the entire precinct was defined by a physical boundary. And those who were supplying parts and supplying additional contract labor had to enter the wall through a fairly robust security gate. In today's world, that same organization, I presume, is doing business with the same suppliers electronically, so much so that only the final delivery may appear on the doorsteps. You must have experienced that through Amazon, through Flipkart, and so on. So please keep in mind that your organization may not even have a physical boundary and will be defined by electronic boundaries, which are fuzzy. So collaborative platforms, as a result, assume tremendous significance. We also find that when it comes to digital leadership, you will not be sitting on top of the pyramid. The traditional hierarchical structures of organizations were already disappearing. But when we have big data and artificial intelligence, not only analyzing data, but also making decisions or supporting decisions, then you don't need that pyramid structure. Even defense, which was the main sample or example of a hierarchical structure, is now becoming flatter due to digital technologies. And the flatter the structure, the greater is the importance for the leader to be less of a manager and more of a facilitator. And that's a change in psychology of how we considered leadership in the past to a decentralized leadership. The success of a company, a digital company in a digital economy with fuzzy boundaries, is not going to be decided only by the parameters of stock market. Success, as we understand in the Western thinking world, and India is a part of it, is where the company has to show great growth in its stocks for the leader to be rewarded. What we are discovering, that there is actually something quite different than success, and that is significance. And how a company becomes significant in your lives and my lives will decide whether it should be called successful. So there is a bit of play of words here, but in the digital world, we are discovering that the traditional parameters of stock market as a success for a company may not always hold true. And that is something you need to keep in mind. Different designs, different processes, different values for the company, different mission statements will reveal that the company is playing the role of significance in its clients' lives. So here we are, changing values, shrinking of time, and collaboration in especially Amazon. And it comes to my mind because I have actually seen Amazon supply centers, warehouses in Sydney, in here as well. And these gigantic centers are working on collaborative automation. In case some of you plan to do further research, even in your current studies, this is for students, you want to do research, there is a very popular acronym, RPA, Robotic Process Automation. And that's something to keep in the back of your mind when we talk about collaboration. We discover, this is my ongoing research, we discover that profit only motives are actually not working. And that's what the great leaders that I interviewed were telling me. In one sense, really, the leadership responsibility is to make the organization move faster, change faster. Now we see that in India, in US, in Australia, in rest of the world, that a decision that is taken is actually implemented much faster than ever before. And technology is playing a role. And that's what I call agility. In the context of the business agility, the leader has to move the organization rapidly into a uh, flexible, nimble organization. And therefore, the comparison between significance and success comes into play. How can an organization move faster, and why should an organization move faster? The traditional answer would be because we want to make more money. But the digital answer is because we want to play a significant role in the lives of our clients. So there is a opportunity for composite balancing act between flexibility and rigidity. And again, the study that I'm conducting is also discovering that a fair amount of how the clients, how the users view a organization is subjective. You might have a different value than I have. And therefore, I might say, oh, yeah, that flight was not bad, even though they lost my luggage. And you might say the flight was horrible, although everything came on time, but perhaps you were upset with some lack of service. And then you go and post it on Facebook and it goes viral. The word viral is important. It indicates that subjective interpretations um, can actually twist future of countries. Okay, risk and failures. If success is aimed at the cost of significance, it's a red flag. Automation in decision making without due consideration to biases in data and algorithms, another big topic. And full automation, like a Tesla car, for example, without superimposition of natural intelligence, which is what Professor Tad and I have argued in our book on AI, not remembering cybersecurity with every breath, and governance, risk, and compliance that I had mentioned. I also asked my participants whether they thought that there should be more thinking techniques, additional thinking techniques for digital leaders than the ones that we have learned. All of you who have studied masters, any master's course must have encountered, deep Bono's six thinking hat and various other blue sky thinking and various thinking techniques have been developed. And the gurus of digital leadership say that value focus is absolute must, because one bad customer can ruin half the business or more. Flattening of the organizational structure. Nobody can behave like a boss. They have to behave like a facilitator. And Scrum has a very good word for it, formal word, servant leadership, incorporating data-driven insights and thinking strategically for cybersecurity, not just tactically. These are the various levels. I want to focus a little bit on some important slides, and I may speak for another 3 to 5 minutes and then open up for questions. Here is something else that came out as very important, and that is this word XAI. In fact, this is becoming a rich area of research. So faculty that wants to move further, do postdoc, or those who are looking to do their PhDs from a research viewpoint, those who are practicing will have to study this as well. What is happening with AI is it makes the organization agile. That means it makes rapid decision making. For example, you want to know if India is going to win the ODI, the World Cup, and you ask artificial intelligence, which will not only go through linear data on the history of winning and losing, but also the weather, also the factors in the stadium, the mood of the players. There are factors that are subjective, but that impact decisions. And AI can incorporate if it has been coded. And the whole idea of machine learning is that a machine is learning based on the decisions being made. Now, if the original data is biased, or if things are really, they have been predicted in a way that doesn't comply with our thinking, human thinking, we have to ask the system why. And whether we like it or not, the entire AI, ML, big data drama is based on correlation and not causation. And this is a mantra. AI is based on correlation and not causation. And therefore, you need to incorporate explainability when it comes to biases, when it comes to legal requirement. There are age biases, gender biases, various color, race, various types of biases. And AI cannot be allowed to make decisions without explanation. And I wrote this particular article for Qatar on explainability. If you are interested on a personal basis, I can share it with you. I can't put it up somewhere because it belongs to Qatar copyright. Okay, I'm going to skip this right now because I have already mentioned that I did talk about the importance of significance against success. And that means the digital leadership needs to keep the compassion angle in mind even more than in the past. In the past, also leaders were compassionate. I know my experience with Tata company, there was a significant amount of CSR, but even more is needed now in the digital world. Here I have focused on the subjectivity in value extraction, again coming out of my book. I don't think I have the time to do justice to it. And this is more on how governance is impacted and government. I'll skip this. I want to also skip all of this. Um, I just want to highlight in this subsection that digital leaders need to keep in mind people. And here I'm not talking about only the users, in fact, less of the users and more of the stakeholders within the business, within the teams, within the projects, within the organization. And that is because data science people, data scientists are one of the hottest communities in the world right now. And there are many variations. Even students learning Python and Java in my university are able to jump into Google and Amazon and Microsoft. And a digital leader has to manage his or her assets, people assets. And these are the various, these are the names or titles that a business analyst comes across that a leader has to worry about, that a leader has to deal with. Okay, I talked about the balancing act. I do want to highlight cybersecurity. I'm not a cybersecurity expert, but I sometimes feel that nobody is because the whole thing is so vast. Also, those who are the bad actors, those who are the ones who are attacking, are highly intelligent people. So cybersecurity becomes a challenge because policing cybersecurity requires the same amount of intelligence, if not more, and the same smartness and the same speed. And the various types of attacks and the various ways in which you can respond and the speed with which you respond becomes crucial. One of my past PhD students, Dr. Girish Nair, is doing a postdoc work in if the companies had a preparation for what to do when a cyber attack happens, then those companies were able to recover faster. This is not something dramatic. This is very simple, basic. But we are doing a study on it to stress upon the businesses how important it is that they have a cybersecurity strategic approach, which requires time, money, people, training, and AI can also be used in order to help support cybersecurity. I have highlighted significance, but here I'm simply telling you how my research is going. I have done the interviews, most of them. I can still take a few, but I have to start analyzing them. Right now, I have reached, I think, 40 plus, so about 46 or 48. And young Keith Sheringham, who is sitting in the audience right now, has also been interviewed for this study. So in case you have some ideas, some thoughts, you can reach out to me on that. I don't think I will read it out, but this is really what I had planned to talk. And I just hope that it has been of value to you. I will conclude by this very well stated fact by Dr. Deepak Chopra, who is one author I really enjoy reading. And I may have even quoted it in the past. If you have heard me in the past, you might even remember this. Technology is our creation, and that includes digital technology, of course. We weren't created by technology, at least so far. So let's use our creation, which is digital technologies, to bring about a healing. At the most fundamental level, we are not just connected, we are inseparable. And this word inseparable in comes or is expressed very well by the Sanskrit word Advait. So here I am. Thank you for the opportunity to speak. Thank you for listening. You are invited to connect with me on LinkedIn. Drop a message saying this is where you heard me. This is one of my two email addresses. The other one is bhuvan.unhelkar@gmail.com, and this site is fast asleep right now. It has got my old resume, but I have to update it. I will do it soon. So that's about it. Thank you very much. I'm going to stop sharing and see if you have some questions.
Thank you, sir,
All
for
right.
imparting your words of wisdom with us. Now we are open for question and answers. If any of you have any questions, please raise your hand.
Hello, sir. My name is Neil. I would like to understand that if a company is working well with the traditional way of leadership, how would you implement this digital leadership for them? Like, how would you convince?
Right. I think, by the way, Neil, thank you for asking the question. A company that is doing well in a traditional format will suddenly find that its business partners are moving forward. If we look at the whole digital ecosystem, and I mentioned the example of a airline. If an airline thinks that it can remain non-digital, how is that possible? Uh, if we look at even the massive employer, the massive company called Indian Railways, which I'm very fond of because I'm the son of a railway man. And it has to also move forward digitally. Sitting here in Florida, I am able to book tickets to go from Bangalore to Pune if I want to, and I have done that. And that's because that giant has also moved forward in the digital world. IRCTC is the site. I would convince whosoever are the stakeholders, whosoever are the business drivers and business owners, to consider the fact that the entire world is moving in the digital space. If you look at a bank, in fact, Paytm, you don't have to go beyond Paytm in India to convince a company to become digital. But it is not only collection of data and keeping it somewhere. Very simply, you and I, we take photographs with our cell phones. I mean, I don't even, I just use my phone and click, click, click. I don't say 1, 2, 3. I just take 3 photographs of every event or situation, and then I select the best one. But am I able to go into my database of photographs and select the best one? When the time comes, I basically select anyone that is available to me. So you have to convince the stakeholders to not only source and store data, but also be able to analyze it quickly so that decisions can be taken. And finally, if the government moves forward in the digital world, you are left with really no choice as a company and also as an individual. And that is the third um, argument. And of course, the fourth is cybersecurity. You cannot live in a world where you have built a wall around you and there is no door. There has to be a door, and that door is going to be a digital door. So a company really has no choice. And I would be surprised if a company is doing well without being digital. I hope that helps you, Neil.
Thank you, sir. That clears it up.
You're welcome.
Thank you, sir. Anyone else?
Sir, my name is Ashutosh. I want to know how AI can help in field of cybersecurity, because I think in cybersecurity or in a malware attack, things are not predictable. But for AI, we have to program or linear regression data. So I don't think it will help much in the sector of cybersecurity.
Well, you're right in one sense that there is unpredictability, but then the question is, if AI cannot help in situations that are unpredictable, then why do we even need AI? Because then we can easily handle things that can be
I
predicted.
think AI is just needed to elevate things which we know. Like if I know some of our thousands data, I am just taking an example. So I can use AI to elevate that thing, but it cannot help in unpredictable situations. I cannot
Well,
depend on AI to protect myself on a malware attack.
that's a good observation, but let me assure you that AI is absolutely being used to predict the possibilities, to predict the attacks. And I'll tell you where and how it is done. And I'll give you only a simple example. There are a lot more. A AI-based system will monitor who is logging into the company's databases during what time periods. For example, if the company is spread out globally, there are people logging in from New York and from Bangalore at different times. If there is a login from New York that is at 2 a.m., then AI-based system will immediately start flagging that something seems to be amiss, something is going on here that you should look at. Something that in normal system, a system that does not have the advantage of analytics, will not be able to do. There are there is the concept of a digital twin. I want you to go and explore that, Ashutosh, when you get some time, and you will find that AI domain is now building a twin of a real life situation. It could be um, a big dam, or it can be the president of a country, or a fighter jet. There are digital twins being created. These digital twins are provided input of the same parameters that are impacting a real life situation. And AI-based analytics are able to say whether a dam will burst, or a fighter plane will go down, or someone is going to get cancer. The same logic applies to attacks. Here in my university, we have a center for cybersecurity. And the first thing you see when you enter the center is a big display board on which they are saying how many attacks are happening right now. And it's in real time. And it is a great thing to watch, because there are as much of data as is getting collected. There are hundreds of attacks happening per second, literally. So the whole screen is flashing all the time, as if data is being monitored, as if data is being sent and received. So please do keep in mind, and I do encourage you to think more. I enjoy the arguments you're putting forward, but AI is being used. I'm not saying will be used, is being used to monitor cyber behavior, and also make predictions in terms of irregularities of access, who is accessing, how much of it is regular and how much is irregular. And based on user behavior, it is able to make predictions that some things are wrong. Please go and have a look. It may not be um, what do we say, prescriptive, in the sense it may not take action immediately,
Yes, that's
but
what
it
I'm
can
asking.
predict.
It can take action or not.
It depends on how you
So
program it, isn't it?
it is taking action or not in current situation. Is AI taking any action against their attacks? Or I have,
Yeah,
for what you have said, I have understood that it can flag or just indicate that we are in danger. But can it help to solve a situation?
none of the AI applications will actually be able to solve. So in my book, I have argued for the need for natural intelligence to be superimposed on artificial intelligence. The explainability discussion that we had in my presentation is also highlighting the need, not only that AI cannot take automated corrective action, but should not take automated corrective action. But then if you are driving the top end Tesla, really the need for steering wheel is going away. Okay, I appreciate your input. Let's take this discussion offline, um, because it can be very, very interesting. Thank you, Ashutosh.
Thank you, sir.
You're welcome.
Thank you, sir. With this, we conclude the session. We hope that it was enriching and informative experience. I once again, on behalf of the fraternity of Amity University, Uttar Pradesh, thank all the guests and dignitaries for their significant presence. We would also like to thank the students for their cooperation. Thank you, sir.
Thank you, everyone. And thanks, Keith. You take care and stay safe and come back to Australia soon. And Garima ma'am and Richa ma'am and everybody, thank you very much. Bye-bye.
Respected Professor, ladies and gentlemen, at the outset, I, Sanya Bansal, and my co anchor, Mohammad Farnaz Faisal, express a warm and respectful welcome to the 14th International Conference, Confluence 2024, Cloud Computing, Data Science and Engineering, organized by Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated towards its responsibility of imparting its students with strong foundation and a platform for empirical inquisition. With this agenda, Confluence 2024 intends to bring together professionals, academicians, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovation, share results, and new directions in the field of next generation technologies. It is our great privilege and honor to have amongst us Professor Dr. Arif Sarawat. Dr. Arif Sarwat is a professor in the Department of Electrical and Computer Engineering and also the director of FIO FPL Solar Research Center. Dr. Sarwat received his master's degree from University of Florida, Gainesville, his PhD from University of South Florida, Tampa, and currently leads the Energy Power and Sustainability Group at FIU. His research interest includes smart grids, plug-in, hybrid, and electrical vehicle, PHV and EV system, high penetration renewable systems, grid resiliency, large-scale data analysis, advanced metering infrastructure, smart city infrastructure, and cybersecurity. His outstanding contribution led him to become the recipient of NSF Career Award in 2016, multiple federal and industry research awards. He was the co-author of Conference Best Paper Awards at the Resilience Week in 2017 and a Journal Best Paper Award in 2016 from Modern Power Systems and Clean Journal. Dr. Sarwat worked at Siemens for more than 9 years, winning 3 recognition awards. He is a chair of IEEE Miami Section VT and Communication since 2012. Now, I request Professor Dr. Arif Sarwat with a huge round of applause to kindly express the gathering with his words of wisdom. Please, sir.
Thank you very much. I didn't expect such a long introduction. Appreciate it.
Thank you, sir.
Can somebody remove the recording, stop the recording, so then I can put the slides on. Unfortunately, we are not allowed to record here.
So we're actually working on it. It is supposed to be done by the backend team.
Okay.
It'll take some
All right.
time, so.
Okay. So in the meantime, we maybe I can hear from the students what background are they from, so that I can tailor my presentations to them.
Okay, so.
Good morning, sir. My name is Kuvam Sethi and I'm from Data Science, CSE.
Awesome. Okay. Which year are you in?
Second year, sir.
Second year.
Fourth semester.
Wonderful. So they're all from continue, but most probably they're all from second year, I suppose.
Good morning, sir. I'm Vanshama from Data Science.
Okay.
Good morning, sir. My name is Ahonudas and I'm from Data Science second year. I'm really passionate about what you are going to say about cloud computing and stuff. So I'm looking out for it.
Wonderful.
Sir, I'm Anushka from Data Science second year.
Awesome.
Good morning, sir. I'm Zoya from Data Science second year.
Wonderful.
Good morning, sir. I'm Arpita from Data Science second year.
Thank you.
Good morning, sir. My name is Aman. I'm pursuing my bachelor's degree and I'm currently in second year in computer science.
Mhm.
Hello, sir. I'm Nandini and I'm pursuing BTech in Computer Science and Engineering.
Wonderful.
Good morning, sir. I am Suyas. I am currently pursuing BTech Data Science and I am in second year. Thank you.
All right.
Good morning, sir. I'm Shivang Joshi and I'm pursuing BTech Data Science and I'm in second year.
Good morning, sir. I'm Vatsalengi. I am pursuing computer science, data science, and I'm also in second year.
Okay.
Good morning. Good morning, sir. I am Harman Singh. I am from 4th CSE IoT.
Wonderful.
Good morning, sir. My name is Adarsh and I'm pursuing BTech in CSE and I'm currently in second year.
Wonderful.
Morning, sir. I'm Shreya and I'm in CSE second year.
Good morning, sir. My name is Varun Goyan and I'm currently pursuing BTech in data science.
Okay.
Good morning, sir. I'm Abhigan and I'm
Go ahead.
Good morning, sir. My name is Harsh and I'm doing CSE second year.
Good morning, sir. I'm Harsh Verma, pursuing BTech CSE, currently in India.
Good morning, sir. Myself, Ayan, and I'm pursuing BTech CSE and I'm currently in my second year.
Good morning, sir. I am Himanshi and I am pursuing BTech CSE from Amity.
Good morning, sir. I am Kanak Jain and I am from BTech Computer Science.
Wonderful.
Good morning, sir. I am Mukul Yadav. I am a second year BTech student. I look forward to this session.
Thank you.
Good morning, sir. Myself, Omika Rena. I'm pursuing BTech in Computer Science and Engineering. I look forward to your presentation.
Wonderful.
Morning, sir. I am Anvita. I am pursuing BTech from Computer Science and Engineering.
Data Science and Engineering, organized by Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated towards its responsibility of imparting its students with a strong foundation and a platform for the empirical incursion. With this agenda, Confluence 2024 intends to bring together professionals, academicians, industry experts, researchers, enthusiasts to discuss various emerging trends and innovations, share their research results and new direction in the field of next generation technologies. It is our privilege and honor to have amongst us Professor Shong Lang Lu. Professor Shong Lang Lu is the director of Sydney AI Centre and an associate professor at the University of Sydney, Australia. Shong Lang Lu has published more than 200 papers at the leading AI ML conferences and journals. He received the Core Award for Outstanding Research Contribution in 2024. IEEE AI's 10 to Watch Award in 2023, Eureka Prize shortlist for Emerging Leader in Science in 2023, ARC Future Fellowship Award in 2022, Faculty Early Career Research Excellence Award in 2021, and the ARC DECRA Award in 2018. He received multiple faculty awards from the OPPO and Musion. Shong Lang is also very proud of his talented students who have made, are making, and will make significant contributions to advancing science. They have also been recognized by many awards, example, Google PhD Fellowship Awards. He is an affiliated associate professor in machine learning with Mohammed bin Zayed University of Artificial Intelligence, United Arab Emeritus, a visiting professor of University of Science and Technology of China, a visiting scientist or IRKEN AIP, Tokyo, Japan. Now I request Shang Langlu sir to kindly address the gathering with his words of wisdom. Please, sir.
Thank you. Thank you very much for the very nice introduction. Can you hear me very well? I believe so.
Yeah, he's there.
Okay.
Yes, sir.
Okay, good. And also, I would like to thank the conference organizing committee very much for inviting me. Okay, and today I'm going to give you a talk, Machine Learning with Noisy Labels. Learning with noisy labels is at the early stage. Maybe many of you don't know this topic, but I hope that after the talk, you will roughly know the philosophy of how to deal with noisy labels in the real world applications. Okay. So first of all, I would like to promote trustworthy machine learning. Now we all know that trustworthy machine learning techniques and tools are widely deployed into our life. So the machine learning and machine learning techniques and tools are trustworthy if they are explainable, robust, fair, causally responsible, privacy preserving, etc. Okay, and as the machine learning tools and the techniques has been widely deployed. So it is a foundation. The trustworthiness is a foundation for our society to further develop and deploy those techniques and tools. And today we will focus on a subtopic which is called algorithmic robustness. So what is algorithmic robustness? We all know that for machine learning algorithms, they have input and output. So the input data and they will output some hypotheses, for example, for classifiers. Usually, the input data are of high quality and the output classifiers will perform well. But under some situations, the input data are of low quality. Okay, then the output hypothesis will also be of low quality. However, we hope that the algorithm will output high quality data for, high quality hypothesis for deployment. Okay, so if an algorithm can output high quality hypothesis, even if the input data is of low quality, such algorithm is called a robust algorithm. And today we will deal with noisy labels, which means that some of the labels in the training data are incorrect. So it's obvious that the data, input data is of low quality. And then we will discuss how to design machine learning algorithms which will output high quality hypotheses. First of all, we will discuss why should we care about label noise. We all know that the data size is going bigger and bigger, right? Previously, in machine learning community, the data set has a small size, and we can accurately label all the data point. But now the data size is growing bigger and bigger, so it's very costly, time consuming, and require a lot of labor effort to accurately annotate all the large scale data set. To solve this problem, many cheap method has been proposed to quickly annotate data. And of course, the labels are not reliable. One famous example is the use of the Amazon Mechanic Turk. Okay, for example, we have a very large scale of data set, billions of images. And then we can divide the data into small subsets. For example, one subset can contain only 10 or hundreds of images. And then we distribute those subtasks online and ask some expert to label the data. And then we pay for the annotators. Okay, some annotators would try to earn more money, then they would randomly and quickly submit some labels. Of course, the label could contain errors and then are not reliable. There's many reasons. So we just summarize three major reasons which will cause label noise. The first one is that, as said in the example, many labelers now are not expert. They may make mistakes. And the second one is that for many labeling tasks, it is very subjective. For example, for a very complicated disease, even for very experienced doctors, they may make different decisions or diagnoses. And the third reason is that now many data are of low quality. The data contain insufficient discriminative information. For example, we can present you an image, but the image is very blurred. It's very hard for us to see the content. Then, if we ask you to annotate the image, high likely you will make some mistakes. Okay, of course there are many other reasons. We believe that label noise widely exists. Is it harmful? The answer is yes. Those two pictures are cited from this iClear paper in 2017, and this paper was the paper won the best paper award in 2017. So on the left-hand side, this figure shows the vertical axis shows the average training loss, and the horizontal axis represent the training steps. And for different curves, we can see that specifically for the right curve, the training data represents that the training data contain label errors. So we put some random labels to the training data, and we can see that as the training steps grows, and the average training loss will decrease and vanish to 0, which means that the model will fit the training data very well, even it contain label errors. Okay, the right-hand side figure shows that. Okay, first I will explain. The vertical axis represent the test error, and the horizontal axis represent the rate of label corruption. For example, 0.4 here means that 40% of the training errors are incorrect. Okay, as we can see that as the label corruption rates increase, the test error will also increase and almost approaching 90%. So this is those are the results for the 10 classification problem, which means that when the label corruption rate is very high, the hypothesis or the models we have learned will make very poor classification predictions. Okay, on the left-hand side, the model during the training procedure, the model fits the data very well, but for deployment, when we check the test error would be very high when there is label noise. This is a very typical phenomenon in machine learning, which is called overfitting. So label noise is a kind of noise, and the machine learning models will easily overfit the labels and thus cannot generalize very well. So label noise is an issue. And also, we know that model selection is also very important in building machine learning models. So for example, to train deep networks, a lot of hypotheses will be generated. For example, in each training epoch, and we have a set of parameters, and it corresponds to a model, right? And we have many epochs, and we have many different models, and which one should we deploy for example, for deployment and to have a check for the test error. Usually, we will use a validation data set to check which model will have the best performance, and then we choose the model for deployment. And if there's label noise, which means that the validation data may also contain label errors, so the traditional model selection or the model validation method will not work very well, and it will provide suboptimal solutions. So I would like to say that label errors is harmful during the model training procedure, and also is harmful during the model selection procedure. Now, you may have the feeling that, okay, label noise is the issue for the large scale data set, and it may have nothing to do with maybe small scale or medium scale data set in academia. But the feeling is incorrect. Here, I would like to show you a result presented by colleagues from MIT. And they checked the test data set and the validation data set for 10 popular data sets in computer vision, natural language, audio data set, which have been widely used in academia. For example, MNIST, CIFAR, and ImageNet. I assume that many of you may know some of the data sets very well. And they reported that on average, there are 3.4% of labels in the validation data set or the test data set are incorrect. And then more specifically, for this ImageNet data set, we know that the ImageNet is very important for the development of deep networks. And for the ImageNet data set, its validation data set, there is around 6% of the labels are incorrect. And then normally we assume that the training data and the test data and the validation data set, they have the same distribution. So we can also infer that for the training data of the ImageNet, they also contain around 6% of incorrect labels. And in this page, I would like to show you the top one accuracy of the performance on the ImageNet, the data set. And we can see that then in the year almost 2024, the best performance is around 95%, very high accuracy. But we should know that the data, the training data and the test data, they contain 6% of incorrect labels. And we can easily infer that those models would have fitted the label errors. Okay, if we have a clean data set, and we believe that those models would be further improved for the accuracy. And also we want to discuss that label noise is also an issue for the building of foundation models in the real world. We all know that now the foundation models are very popular and has a lot of very important and interesting applications. And I would like to set the GPT as an example to show how they use data. Okay, for example, for GPT-3, 175 billion data parameters have been used, and around 500 gigabyte data has been used. And we should also know that those data has been carefully selected. And those data, for example, are selected from those common crawl data set and those web text data set and some book from some books and Wikipedia. And we have the sense that all those data, they are of high quality. And based on those high quality data, now the foundation models have very good performance. However, even with those high quality data, the engineers and the scientists, when they train the foundation models, they also use some tricks to avoid the model overfit the errors, to overfit the noise. And later we'll show you that those methods, for example, early stopping is a very well known method to handle data noise. And also they put different weights to different data. If a data is of high quality, then they put more weight. If the data is of low quality, and they put a small weight on those data. We all know that to build very promising large language models or foundation models, the three elements are very important. The first one is that we should have enough computing power. And the second one is that we should design very efficient and effective machine learning algorithms. And the third one is that we also should have sufficient data to train the model. Okay, and we know that in the real world, actually, currently the data size is limited. Okay, and those, for example, OpenAI, they just make use of those high quality data, and there are also a large number of low quality data, which may contain label errors. And those data haven't been used. Okay, we can easily find that if we want to further improve the performance of large language models, and we want to build better foundation models, we may have to use those low quality data, which may contain a lot of label errors. Okay, so in this talk, we will introduce you later how to deal with those label errors. So now I would like to quickly make a summary that label noise is ubiquitous in the real world, and it is harmful both during the training procedure and also during the model selection procedure. And also we would like to emphasize that to further improve foundation models, we may have to use those noisy data in the real world, which may contain a lot of label errors. Now, how to deal with label errors? And we will introduce you the philosophy high levelly. So we first present you the setting, what we have and what we want to learn. What we have is a noisy training sample. Okay, this XY pair is called a training example. Those N training examples will make a training sample. So this Y tilde represent a noisy label. Noisy label does not mean it is incorrect. It could be correct and it could be incorrect, but we don't know. And for this training sample, there contain some label errors. So our aim is to exploit those noisy training data, and we want to design a machine learning algorithm which can output a very reliable classifier. So what is the best classifier? According to the statistical machine learning theory, the best classifier is defined by using the class posterior. This P of y given x is called the class posterior. And given an instance x, we would like to check which y has the largest probability, and then we assign the label to the instance. This classifier is also called the Bayes classifier. So again, the setting is that we only have a noisy training sample, and we want to design machine learning algorithm which can output a reliable classifier, which if the classifier can approach or could be identical to this Bayes classifier, that would be the best. Normally, there are two categories of method to deal with those noisy labels, because those label errors will have some side effect. As said, it will introduce overfitting, okay, for example. So one major method, category of method is to extract confident examples. Confident examples are those examples whose labels are more likely to be correct. Because we have a very large scale of data set, we just extract a subset of confident examples and train the machine learning models on those confident examples, we would have good performance. And a lot of method has been designed, and they have done experiments and showing that the models trained on those extracted confident examples have good performance. And the second major category is called label noise learning. We want to study the properties of label noise, or more specifically, we want to model the label noise. We want to know the properties, and we want to handle the label noise. And we will introduce you the two categories, the philosophy of those two categories one by one. Okay, for the first category, I would like to introduce you the trick of small loss trick, and which is also closely related to the early stopping method. And I would like to use this figure to illustrate the method. Okay, and for this figure, also the vertical axis represents the training. Here it represents the training accuracy. Okay, instead of training error, it represents the training accuracy, and the horizontal axis represents the training epochs. And for those solid curves, it represents the training data whose labels are correct. And for those dot curve, they represent the training data, for example, the training accuracy of the data whose labels are incorrect. Because for CFAR 10 dataset, we have the ground truth label, and after injecting some incorrect labels, we know the ground truth. We know which data has a correct label and which data has an incorrect label. And then we monitor the performance, the fitting of the different data with correct labels and data with incorrect labels during the training procedure. And here, those red curve represent the setting where the training data contain 20% of incorrect labels, and the orange one represents the training data which contain 40% of incorrect labels. And we can see that during the early training stage, the model that would fit the data with correct labels. The data with correct labels have high training accuracy. However, the data with incorrect labels will have low training accuracy. And after, during the late stage, training stage, the model then will fit the data with incorrect labels. So this is an empirical observation, and this phenomenon is called the memorization effect of deep networks. And the reason behind it is that for the deep networks, which contain a lot of parameters, when we train the model would first fit the majority patterns of data, and then fit the minority patterns of the data. Usually, if the data contain label errors, the majority of the data will assume that the majority of the labels are correct, and only a minority of the labels are incorrect. So if the model fits a data, for example, fx is a prediction, okay, fits the data very well, which means that fx would be close to y tilde, the given label, then the loss would be small. So during the early stage, we can check if training data has a small loss or not. If the data has a small loss, then the label would be more likely to be correct. Okay, so this is the philosophy of the small loss trick. Okay. So also, I would like to make a quick summary here. There's two categories of methods to handle the label noise issue. One is to extract confident examples, and the popular method, representative method I have introduced is the early stopping method, or the small loss trick. And another category of method is to model label noise. And in the following section, I will show you how to model label noise. Okay. To model label noise, we should have some assumption of how the label noise is generated. Okay, so which means that we should set two models for the generation of label errors. The first one, I just present you two models. Okay, the first model assume that this P of x given y tilde, this is called noisy class conditional probability, has a relationship with the clean class conditional probability. P of x given y is a clean class conditional probability. Okay, and we assume that the noisy class conditional probability has this relationship with clean class conditional probability. And then the noisy data could be connected to the clean data. Okay, this is one assumption. And another assumption, or another model, assume that the noisy class posterior, okay, P of y tilde of x is the noisy class posterior, has a relationship with the clean class posterior, P of y given x. Okay, and we will show you that the second model is very general, which means that the assumption is not very strong, because by using the law of total probability, and we can rewrite this noisy class posterior into this equation. Okay, by comparing the two equations, we can find that the beta actually equals to this probability. The probability represents an instance whose clean label is I, but the observed noise label is J. Okay, this is the event, and the probability of the event is denoted by beta. Okay, and actually this probability represents the relationship between the noisy label and the latent clean label for instance. And we can further rewrite this equation into a vector form. For example, this noisy for the noisy class posterior by using the law of total probability, and we can write it into the betas and this clean class posterior. Okay, we just rewrite that into a vector form, and now we can see that the matrix in the middle is very important, because those noisy class posteriors can be estimated. We have a noisy training sample if we have a very well-trained classifier, a calibrated classifier, which can estimate this noisy class posterior well. So our aim is to learn the clean class posterior. As I said, we can use the clean class posterior to define the Bayes classifier, right? Our aim is to learn the clean class posterior. The noisy class posterior, for example, is given, so the matrix in the middle matters. And the matrix in the middle actually represent the relationship between the noisy labels and the clean labels. And we denote it as a label transition matrix. The label transition from the latent clean label to a noisy observed label. Okay, so if we could learn the transition matrix, given the clean noisy class posterior, the clean class posterior information can be inferred. And in the later, we will discuss how to estimate the transition matrix. Okay, again, the setting is that we only have a noisy training sample. We don't have any access to clean data. Of course, if there is some clean data, it is very helpful, but we just focus on the very challenging setting where we only have the noisy training sample. Okay, our aim is to learn or to estimate the transition matrix T. Okay, to learn the transition matrix T, because it matters how many the probability that the clean label flip into the noisy label. Given the noisy data, if we know the transition matrix, we may know how many labels in the data are incorrect. So this is a very challenging task. And also, given only the noisy data, to learn the transition matrix is an ill-posed problem, because the task is to factorize this noisy class posterior into the matrix and the clean class posterior. This is a matrix factorization problem. If we don't have any prior knowledge, the factorization is not unique, which means that the problem is ill-posed. Okay, to make things easy, and we may just assume that the transition matrix is independent of instance. For different instance, the label errors have the same pattern. So this is just an assumption, maybe strong, but later we will release this assumption. If we just assume that the label is independent of instance, then it is called the instance independent label noise. Then our aim is to, can we introduce some prior knowledge such that we can learn, we can identify this transition matrix and then estimate the transition matrix. Okay, so I would like to present two methods. One is called the two assumptions. One is called the anchor point assumption, which was proposed in 2016. And another one is called the sufficiently scattered assumption, which was proposed in SML 2021. And then the first assumption, anchor point assumption, is a sufficient assumption, but not necessary. So which could be strong, and the sufficiently scattered assumption is a sufficient and a necessary assumption for identify this transition matrix when the label noise is instance independent. Okay, due to the time limit, I can't present you more details, but if you are interested, you may read those papers. And then for the real world problems, the labels errors would depend on the instance. Okay, for different, for example, different image. If an image is very clear, then it may contain lies label error, right? If the image contains insufficient discriminative information, as discussed, it may contain more label errors. So the real world label error should depend on the instance, which is called the instance dependent label noise. So how to identify this function valued, matrix valued function, okay, a very complicated function is very difficult. And we have introduced some effort. The first one is that we have introduced the Bayes label noise transition matrix to make it easier to be identified. The second direction is that we can make use of the causal information. So for data, for example, data for a data set, we have X and we have variable X and a variable Y, and there's some causal relationship between X and Y. And those causal information will describe how the data is generated. Causal information contain more information than dependence. So in this paper, NeurIPS 2021, we show that by using causal information, we can better identify this, not better identify, to make this transition matrix to be more constrained. Okay, then will lead a better estimation for the transition matrix. For more details, if you are interested, please refer to those two papers. Okay, now we also would like to make a quick summary. There's two different methods for dealing with noisy labels. The second one is to model the label noise. Okay, how to model the label noise? We have some assumptions, or we have two assumptions or two models for how the label noise is generated. And also we focus on the model which the noise is generated by contaminating the class posterior. Okay, and then we discussed how to make the transition matrix to be identifiable. If that is identifiable, and to learn to estimate the transition matrix is not a difficult problem. But I haven't introduced the details due to the time limit, and just now we present 4 papers, and actually there's many other papers as well related. If you are interested, please read them. And also you can find my email address, or feel free to contact me if you have further questions. And we have roughly introduced you the philosophy, okay? But actually there's many details from the heuristics to theory. So we have a book which contain those heuristics and theories, which will be published by MIT Press. Hopefully it will be published in this year. And if you are interested, please have a look. Now I would like to overall make a conclusion and point some future work. And as said at the very beginning, learning with noisy labels is at a very early stage, but label noise is ubiquitous in the real world. And which means that to handle label noise is very important. The research topic is very important. And the method to deal with label noise can be used directly to detect label errors and also to detect some write patterns if we want to construct a very accurate data asset. Okay, and also we proposed to model the label noise to better handle it. To model label noise have a lot of advantages. For example, the method is robust to data distribution and also robust to the noise distribution. There's many methods I haven't introduced, so if you are interested, you can read more papers. And also, I would like to point out that in the real world, other than label noise, there's many other noise, feature noise, adversarial noise. Those noise usually are very harmful, and we also believe that there are also some connections between those different noise. How to design a unified machine learning algorithm which are robust to those different kind of noise is also a very interesting and challenging research topic. As said, in the last, I would like to conclude that now there's very promising applications and the deployment of large models, foundation models, and to find good or to find sufficient data to train those foundation models is very important. The real world data is limited, and currently we are just using the small subset of reliable data, and there's many data which are noisy, okay, haven't been exploited for training those foundation models. And we believe that in the near future, those data will also be exploited. And then how to develop the techniques to deal with label noise or different kind of noise is very promising and important. Okay, thank you. That's my talk. If you have any questions, please feel free to ask.
Thank you, sir, for imparting your words of wisdom with us. Is anybody having any questions, please?
Good morning, sir. My name is Aman. Thank you for giving me the opportunity. In the context of healthcare, where noisy labels are affecting medical data sets and utmost care has to be given, how can these be handled?
Thank you, Aman, for the question. And yes, we all care about the many very important applications in the real world. And yes, in healthcare, there's many label noise issue. And I think we should care about this. And one very important aspect is that, for example, for many young or not very experienced doctors, they may have some incorrect diagnosis. If we treat the diagnosis as a binary problem, if the diagnosis is correct or incorrect, let's treat it as a binary classification problem, right? Our method, if we have the data, okay, the healthcare data, and if we apply our method, then we can detect some diagnosis is incorrect, and then we can help improve the expertise of those young or not very experienced doctors. Those, I believe, will be very helpful to improve the our lives, would be contribute a lot.
Well, thank you so much, sir.
Thank you.
Good morning, sir. I am Shreya. And as you mentioned that noisy labels can be harmful. So isn't there any way to identify these labels in the dataset before training the machine learning models?
Thank you for the very insightful question. Yes, there's many methods in this direction. Due to the time limit, I haven't present you those details. So just now we discussed, we can use the small loss trick to extract some data which are reliable, which means that the labels are more likely to be correct. And in the other way, we can also use some method to extract non-confident examples, for example, by using the large loss or some other trick. Data which has a large loss may imply that the labels are incorrect, and then we identify the label error and we can further correct the label, which would also be very helpful to train the machine learning algorithms. And instead of early stop, there's also a kind of late stop. And of course, there's many other methods to detect incorrect labels. Yes, that is a direction and a very helpful and useful direction.
Thank you, sir.
Thank you.
Good morning, sir. My name is Prithvi. I wanted to ask if are there any specific considerations or challenges that you prioritize or things should be prioritized when dealing with noisy labels in large data sets?
So yes, thanks for the question. Yes, because now we are all very interested in the foundation models, the large language models. Just now during the first part of the talk, we introduced that now those companies, when they train the foundation models, they carefully selected the data. So for example, using the data from Common Core, from books, from Wikipedia, and from other high quality data. So they just make use of those high quality data. Okay, there's a large amount of low quality data haven't been used. Okay, this is one aspect. Another aspect is that even they focus on the high quality data, it may also contain some errors and also contain some label errors, right? And they use the early stopping method. They train the large model for 1 round or 2 rounds at most, 2 epochs. So we just introduced the early stopping method would be a very robust method. I believe that for the foundation model, for the companies to train the foundation models, they found the early stopping method is very useful. Otherwise, they could train 3 epochs or 4 epochs or some more epochs to have better performance. I believe that one major reason is that the data contain errors. If we train more epochs, the model would overfit the errors. And some other methods also have been used. For example, a reweighting method. They give the more reliable data with more weight and the less reliable data with less weight. So this all means that label noise is an issue and some effort has been proposed, but of course the problem hasn't been addressed. It is worthwhile to have more effort and we put more effort to design more efficient and effective ways to deal with those errors.
Thank you very much, sir.
Thank you.
Thank you, sir. With this, we conclude this session. We hope it was an enriching and informative experience. I once again, on behalf of the fraternity of the Amity University, Uttar Pradesh, thank all the guest dignitaries for their significant presence. We would also like to thank the students for their cooperation. Thank you.
Thank you, everyone. Bye.
Bye.
At the outset, I, Aditi Saxena, express a warm and respectful welcome to the 14th International Conference, Confluence 2024, Cloud Computing, Data Science and Engineering, organized by Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated towards its responsibility of imparting its students with a strong foundation and a platform for the empirical intuition. With this agenda, Confluence 2024, intends to bring together professionals, academicians, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovations, share research results, and new directions in the field of next generation technology. May I invite Assistant Professor Dr. Kanshi Gupta, Amity University, Noida, Uttar Pradesh, to present a sapling to our esteemed speaker, Professor Dr. Sergio Marquez Sanchez from University of Salamanca, Spain.
Thank you, Aditi. We welcome you, sir. This is on the behalf of Amity family, and we are pleasure to see you over here. Thank you, sir.
It is a great privilege and honor to have amongst us Professor Dr. Sergio Marquez Sanchez from University of Salamanca, Spain. Professor Dr. Sergio Marquez Sanchez is an industrial engineer since 2017 from the University of Salamanca. At the same time, University obtained his technical engineering degree, his specialization in mechanics in the year 2014. At the same time, he obtained a master's degree in design, delineation, and finite element analysis with Autodesk Inventor, SolidWorks, CATIA V5. He has worked as a teacher of robotics, programming, and 3D design, as well as participating in various projects of entrepreneurship, R&D, and product design in fields such as educational robotics and wearable technology. His research interests include smart textiles, electronic textiles, robotics, CNC technologies, PLM software, and circuit printing. Now I request Professor Dr. Sergio Marquez Sanchez from University of Salamanca, Spain, to kindly address the gathering with his words of wisdom. Please, sir.
Hello, good morning. Can you hear me?
Yes, sir. You are.
Morning, everyone. Well, first of all, thank you very much for inviting me again another year more here to Confluence. It's my fourth year, I think, and well, it's a pleasure. I would love to be there presently, but well, actually, I am in my country in Spain, and normally I am living right now in Doha, in Qatar, where I am working in different kind of projects and researching there in energy in this case nowadays. So well, I would like to share, give me a second, my screen. I imagine that you can see my screen right now. All right. So today, wait a second. I imagine that you can see my screen right now. So today I would like to present my work about smart water management. And for this, I create a platform for have the smart water management in smart cities through IoT-based monitoring. I divided my presentation in these different points. that we are going to go through is going to be, I'm going to present a little summary about the literature that we can find in this field. I will present the platform architecture, and from this, I would like to tell you about the key technologies that we can use in this field. Also, how we can implement and test this kind of platform and technologies, the benefit and the applications, privacy and security considerations in this kind of also implementation, and finally some conclusions and future work about this work. So as I said, we are going to talk about water, and in fact right now in the planet we have several problems with the water scarcity, and is going to be the risk number one in 2030. This is because of the increase of the population in the planet, and also because of the climate change, and because the demand is higher than the offer, and this means that we have to link technologies that allow us to have a better control and manage of this vital element for life. Also important to know that only the 0.5% of the planet is fresh water. So it's very important that we take care of it, because if we don't do something to change this issue, the half of the population is going to be in sorry, sorry because of the problems with the connection. Well, I return. I hope that from now you can hear me. I don't know where you stop to listen to me, but well, I was explaining about the issue that we have about the water in the planet. From this issue, what we have to do is to link technologies that we have available as engineers, and I was explaining here about the symbiotic confluence in sensors networks, big data, and cybersecurity protocols that allow us to change the planet. In this case, we are talking about urban water management, and well, there is advanced technologies like IoT that could allow us to face the real-time monitoring, and have also a better control that what is happening in the houses, in the companies, in the all the water cycle. And this is very interesting to link this kind of technologies in the water cycle. And this aligns with the objectives that we have of develop in many countries. In this case, in Europe, we have one that is the six, that is provide the planet or the humans clean water and sanitation, And this is a challenge that aligns totally with a water management system or platform. But there is also other sustainable develop goals that we have that we can attach and we can contribute with this client of technologies. Okay, so the thing here is thanks to all the key performance that give us the IoT asset monitoring systems like real-time, efficient resources allocation, improvement of water quality, resilience to climate change, reduce energy consumption, data-driven decision-making, and citizen engagement. Well, we are going to have a good impact in our facilities and in our companies. We can find already some examples of how water management platform could give us a lot. In this case, I show here two examples. One is in Barcelona, the other one is in Singapore, where they have already these systems, and in real time they monitor and detect, for example, leaks, optimize the water treatment for resources conservation and cost reduction, and yeah, they integrate as well machine learning or artificial intelligence to do predictive analysis, allowing for a proactive issue and anticipation of enhancing water supply resilience. So this is two examples that illustrate how beneficial is to integrate this kind of systems. All right. So from this, I would like to show you here is the platform architecture that I propose from this issue. Everything depends of how big we want to do this water management platform, because it's different if we have a city that we are a user that wants to monitor what is happening in our houses. So in this case, we have the IoT layer, we have the cloud layer, and what we require is devices that have sensors that measure the water consumption, the water quality, pressure, flow level, parameters that are important in the water management and the water facilities. From this, we send through wireless communications. For this, we can use MQTT as protocol, but about the technology, we can use Wi-Fi, LoRaWAN, Sigfox. There is so many different line of wireless communications that will be possible also if it's necessary to send directly to the cloud. We can use 4G or 5G. In some cases, these devices we configure with Bluetooth through an app. In some other cases, it's not necessary. Directly, they connect to internet, and could be also interesting to have an app because sometimes we can see this information, the real-time monitoring in the app, and in other cases also maybe if we have a different platform, or different architecture where we don't have this app necessary is everything from the platform, no? So in the point that we have that information in the cloud, we ingest this information in this kind of platforms. For this, we can use a IoT platform that do this ingestion. For this, we can use, for example, a Google Cloud Platform, Amazon Web Service, any kind of IoT platform. And from this, the visualization of the data information include all the algorithms, all the intelligence that finally give us the key performance indicators about what is happening and visualize in an easy way for the user and the operator and all the different players or stakeholders that we have in the water cycle. Also, it's possible if we have this data information to monetize this data. Something that nowadays is also important. If we have information, interesting information about what is happening in the water cycle, in the water facilities, when the water is in my place, we have information with a value that some kind of companies or public institution will be willing to pay money for. All right, so we are going to do a briefly review about the different layers that we have in the system. In the heart of the platform, we have the sensors. This is one of the most important because we need information about what is happening in our water, no? So we want to do this, but we need something that give us this information. And this are the sensors. And from the sensors, like water quality, this means that we can measure the pH levels or chemical composition, the flow rates and pressure in the water distribution networks. Also will allow us to know if there is a leak problem or no. Composition patterns, temperature, so the potential of freezing thanks to the temperature is possible, and water availability and supply. If we know the consumption, we know how much water we need to provide the users, and we can adapt the pressure in the system and so many other things. So from this data information that we collect, we need to send through wireless communication. As I said, there is so many different technologies, and from these technologies, well, we have to use the right one depend of the scenario. No, it's different when we have, for example, a facility that is in the middle of the countryside than if we are in a house where we have internet connection, than if we have this in the pipes under the streets or on a city, no? So is something that we have to research and study, and depend of the situation, we choose the right technology. From this, we have to ingest all this data information. From this, I was explaining that we need to process the information. Sometimes we process in the cloud with an IoT platform, but in other cases, we have in the middle a node that do this processing, and these nodes are called edge nodes. So from these nodes also could have internet connection or wireless communication. From this, we can do the processing and send to the cloud. And this also give us real-time processing, and well, we can pre-filter the information before sending to the cloud. Um, when we have already the information in the cloud, in the most of the cases, this is necessary to do the visualization and etc. We have, yeah, the power of the cloud is that we could scale the scalability of the system is super high. No, we can adapt our system depending of our necessities, and the data security, the storage, and everything we can put in the cloud, and from this we could have the visualization. It's important to have a user-friendly interfaces. In this case, we are going to have users that we are going to yeah, different users that are going to see this information: municipal authorities, residents, urban planners, researchers. So depend on this, the person, the interfaces have to adapt, and we can have in apps, mobile apps, dashboards, and well, other ways. We have the algorithms. As I explained, we are going to collect this information, and it's important to process the information to extract some insights. And from this, we have to implement some algorithms, and from the real time, we can do an analysis and have a decision making thanks to this. No, we can integrate algorithms for predictive analysis, anomaly detection, and resource optimization. Also, there is a module that is the security and compliance module for the data encryption, access control, audit trails, and compliance checker. That is super important because it's information, sensible information. So we have to be sure that it's not anyone could access that not have the permission, no? Because imagine that if someone have the information about what is the quality of water or the consumption that I have in my house, they can know when I am in my house or when I'm not. So is important information that we have to care about. All right, so from all this review of this architecture, we can extract some conclusions that, well, of course, to use this kind of technologies is going to make us capable to promote sustainable and resilience and drives an efficiency in our cities. Also, if we apply this kind of technologies like artificial intelligence, machine learning, is going to give us a lot of power in the decision making, and we are going to be more efficient and more productive. So it's interesting to integrate different technologies in an architecture of this kind of systems, because thanks to this, we are going to be in a better position in the water management. And well, as future work, well, actually, we already are working in the generation of real environment systems, including all these kind of algorithms. And for this, we are collaborating with the urban planning authorities. And the idea also is integrate the user, the domestic user in this process. And the key point here is the communication of all the infrastructure in the architecture, and of course to not only have the communication and interconnectivity, also that everything works. So for this, we are working hard, and we have some prototypes right now, and we try to scale this to a real water management system. So thank you very much. If you have any doubt or something that you want to discuss, please, I will be super happy to answer you. Thank you very much.
Thank you, sir. May I invite Assistant Professor Dr. Akanshi Gupta from Amity University, Noida, to present a memento to our esteemed speaker, Professor Dr. Sergio Marquez Sanchez from University of Salamanca.
Thank you so much, sir. On the behalf of Amity family, we conclude this session, and we hope that it was an enriching and informative session experience. I once again, on behalf of the fraternity of Amity University, Uttar Pradesh, thank you all the guests and dignitaries for their significant presence. We would also like to thank the students for their cooperation. Thank you so much, sir. Thank you once again.
Thank you, all of you. Hope that you have a great day, a great conference. Thank you.
Sure.
Sir, am I audible? Dr. Ahmed Alnor, sir, am I audible?
Yes, good morning.
A very very good afternoon, sir.
Yeah, good morning from Egypt. Yes, very good afternoon.
A very good afternoon to all the distinguished dignitaries, respected professors, ladies and gentlemen. At the outset, I, Tuba Khan, would like to express a warm and a respectful welcome to the 14th International Conference, Confluence, on Cloud Computing, Data Science and Engineering, organized by Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity School, Uttar Pradesh, Noida. As one of the leading global universities, Amity is dedicated towards the responsibility of imparting its students with strong foundation and a platform for empirical inquisition. With this agenda, Confluence 2024 intends to bring together professional academicians, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovations, share research results, and new directions in the field of next generation technology. So may I invite Assistant Professor Dr. Kanchi Gupta, Amity University, Noida, to present a sapling to our esteemed speaker, Professor Dr. Ahmed Anar, Head of Computer Science Department, Beni Suef University, Egypt. Ma'am, please.
Yes, sir, we are welcoming you.
Yes, good morning. Yes, welcome to.
Editor and reviewer of many young international journals around the world. Dr. Elnar won several awards, including the Young Researcher in Computer Science and Engineering from Global Outreach Education Summit, and awards in 2019 also on 31st January at Delhi, India. Also, he got Best Young Researcher Award in the category Male Below 40 Years Global Education and Corporate Leadership Award GECL 2018. And also, he has an intellectual property rights called EID Dashan or Authentication Protocol Information Technology Industry Development Agency ITIDA technical report. So we welcome you, sir. Now I request you, sir, to please address the gathering with your kind words of wisdom, sir.
Okay. Okay, thanks so much for this presenting me. I'm so happy. I'm so pretty happy to be with all of you today. So good morning from Egypt. Good afternoon from India. I like to be with all of you today. I'd like to thanks all organizers of this conference. I'd like to thanks the president and the vice presidents of the Amity University. Also, I would like to thank the dean of the faculty of engineering or the School of Engineering. I'm also the vice dean and all of you. Special thanks for my dear friend Professor Agual. I'm really thanks so much for her for this to invite me, this invitation to invite me to be with all of you today. This is not the first time to be with all of you. That's why I'm really consider myself to be as a part from the Amity University. So thanks to Professor Agarwal, and I hope to meet personally in the near future. So now let me share my presentation with all of you. Now it's visible?
Yes, sir, it's visible.
Okay. Before we start, I would like to ask all of you to pray for our brotherhood from Palestine, what happened there in between the Palestine and the Israel. So I'd like really to pray. Don't forget to pray for them, because what happened there is really criminal situations. We would like to stop this war. It's very bad situation there. So ask you all of you, please, we need to pray for them to stop that war in the near future, inshallah. Now let us move to our presentation. So my presentation, the title Applied Science and Technology, Multidisciplinary Research Dissemination for the Best Practice in the Distributive Area. Today, really, I would like to be different, because I can see in the whole now more students. So that's why we are here now, because we need to give them the expert. We need to give them the more information about the future, about the science. It's very important to let them understand what we will do and what is the benefit from them. They are the future. Those students is very important for our future. That's why we need to give them our expert. So we need to move to the because my mom introduced me very well, so don't need to introduce myself again. So why I say we need to be different, because I need to give them some ideas, because we need to give them how to thinking about our countries. If we have a problem, we need to let them thinking how to solve these problems. So if we can't do that, so we can't consider ourselves as a researcher or as a scientist. So we need to thinking how to solve the problem, what happened in our our countries. Remember what happened in the past in 2020, what happened the COVID-19, and who solved this problem? What are the scientists who solved the problem? So we need to be stand up a long time to solve the problem. If what happened, so we need to solve it. So outline of my presentation, I will give you the student and our colleagues, because we need to have to discuss the ideas. This is and I invite all of you, if you want to collaborate with me under the umbrella of Scientific Innovation Research Group. This is my group. This is a registered group here in Egypt, and we have many professors from around the world. They are working together, and they produce some papers and the patents and so on. And so I'm welcome all of you. If you want to collaborate, so I'm here all the time. So I need to give some introduction about my work and my interest area nowadays. Especially, I need to focus on one of the best paper and best product. It's very important to say it's lovely paper for me, because this paper is now it's under the vehicle security system using face recognition based on the Internet of Things. This paper and this product under the investigations from the Mercedes. So I hope it will be satisfied, and they can use it in the brand of Mercedes. Yeah, maybe after that I will stop to move on to the industry and working with the Mercedes after that. Maybe, but I hope so. They are now investigate with me and how to employ this product in the car for the security, as a security system for the vehicle, for Mercedes cars. So I will give the problem formulation, the proposed, and what we did, and the implementation result and security analysis conclusion. But now my work especially is depending on two different branches. So I'm working now in the field of the Internet of Things and some of others image processing. And I'm using the machine learning to solve the problem what's happened, because we have already the Internet of Things have many problems. Still have many problems, so you need to know how to solve it. So I'm using the machine learning to solve this, and also the image processing. So I have some papers for the under the branch of the Internet of Things, like a vehicle security system using face recognition based on the Internet of Things, and also Internet of Things based intelligent accident avoidance system for adverse weather and road conditions. And the other one is an efficient user authentication model for IoT based healthcare environment. And I need to talk about some other papers, especially under the branch of image processing, a novel black window optimization or algorithm for the multi-level thresholding image segmentation, because as you know, this segmentation is a very important problem in the image processing. And another papers talk about an improved doing a swarm optimization for global optimization and the image segmentation. And the third paper is recognition of the hand gestures, the image using a deep convolution neural network, and so on. So before that, we need to know what is the Internet of Things. As you know, the Internet of Things is become one of the hottest research topic nowadays, as you know that. So Internet of Things application will affect many aspects of the people's lives. bringing about many convenience. So you still have time to work in the Internet of Things because we don't have any standard of the Internet of Things. So there are three main visions of Internet of Things based on things, internet, and the semantic perspectives. If we talk about, as you can see in this figure, the things vision is the provide the perspective that all real physical objects have a sensors attached to get real-time information from them. So it's very important, as the previous speakers, my colleagues, is talk about the water, and he use also the Internet of Things. And that's why you need to know and understand this very well what is the Internet of Things. One main vision is the things vision. So this vision provide is the base of the integration of all things to collaborate together. The second vision is internet. So this vision provides the perspective that all devices can be connected through the internet and can be described as a smart object. And you need to know what is the difference between the smart object and the Internet of Things object. Without internet, so we can say it's smart, but after that we can, if we provide this object as the internet, so we can say it's Internet of Things object. This can be accomplished by using unique IPs. That's why we need to move from the IP version 4 to IP version 6 because it's developed, the IoT is developed, and we are moved to connect all devices around the world to connect together using the internet. That's why IP version 4 can't give us the unique IPs. That's why we will move to the IP version 6 for each connected object. The third vision is the semantic vision. This vision provides the perspective that all data collected from the carriers or sensors need to be analyzed for the meaningful interpretation. That's why we have already data collected from the sensors connected by using the internet, and now still call this as the data. But now we need to analyze it, to get information. So that's why the decision makers can take a decision in the time, and we need to make it like automated. We need to don't use any the human interaction between those devices. So we need to analyze and take decision, analyze and take decision, analyze and take decision. That's why this vision provides the base of semantic integration through the use of semantic middleware. By the way, all of these visions still have time to put your fingerprint, but now we need to know the standard. We don't have the standard until now. This architecture of the Internet of Things. We have already the standards for the traditional network, internet traditional network, but till now we don't have any standardization of the Internet of Things. So to implement IoT requires an open architecture based on the several layers. Some researchers using the 3 layers, some researchers using 4 layers, some researchers using 5 layers. But now we need to just give a brief of the architecture. It can be primarily divided into 3 layers. The perception layer, such as RFID and GPS and so on, network layer, such as Wi-Fi and Bluetooth and so on, and application layer using some protocols like QAP and MQTT and so on. Fortunately, still have time to put your fingerprint, because if those sensors and devices connect together, how to connect the connections, the internet, the transport layer, one of the most important things of the Internet of Things is security. How to manage the security between those devices, because maybe someone can cut the connection and make mean in the middle, if this application for the healthcare, how can you do if something happened like that? It's very, very bad because we talk about the humanity, how to protect our patients from these hackers or attackers or something like that. So still have time to work in the Internet of Things, and you can put your fingerprint, and you will be as a pioneer of the this field. Now let us move to the our work. The first paper talk about the Internet of Things based the intelligent accident avoidance system for the adverse weather and road condition. Regarding the expert of the good driver at the some point at an intelligent transportation, it's very important that we are in the winter at this time. So we have many problems related to the weather, like fog, wind, snow, rain, and etc. And also what the vehicle velocity, size, weight, and the momentum are reason for the vehicle to go out of control. So an intelligent accident avoidance system can predict the safe speed of the vehicle according to the different weather and route conditions. So the solution is this paper proposed a system comprised of an IoT system that perceive the environment of different weather and route condition and the machine learning based intelligence system, as you can see in this flow chart, so that it can learn and the adverse condition that influence the accident to predict the suggested safe speed to the driver. This proposed system is experimented with the real-time data set and simulated using the Blanket platform. So as you can see, they collect the data and data pre-processing. Then after that, it's sampling into categories and select what the machine learning algorithm is suitable for, like decision tree and the logistic regression and other. After that, we can predict and give the driver the good suggestion. The second paper is talk about under the title an efficient user authentication model for the IoT-based healthcare environment. We are not finished the COVID-19 because there is some converting what happened. I'm not knowing if that happens in India because there is something happened as a convert from COVID-19 to something else now. So we are as a scientist thinking how to solve. We don't need to stop until the problem happened. We need to thinking, and we need to predict maybe something happened else. So how to protect ourselves, how to protect the humanity. So this paper, along with the large scale of IoT network of information technology, user can obtain information sources conveniently via intelligent devices. Therefore, the authentication mechanism, very important, is a fundamental tool for ensuring the secure communication and the validity of the communication parity, especially focused on the healthcare application based on the IoT network. So the solution is, this paper proposes an efficient authentication model based IoT medical data systems for the anonymous user using elliptic curve cryptosystem. It's very important because we are working with the patient, we are working with the humanity. So we need to thinking very well who's use these devices of the healthcare devices or healthcare IoT devices, very important, which achieve the mutual authentication and the forward security. Especially this paper certified the legitimacy of the proposed via the employing a PAN logic, which is one of the important fundamental formal methods. Further, the performance comparison, which is that model is more suitable for the IoT medical application where efficiency and security concerned. Very, very important. You can see here, this is IM construct, and you can use some medical devices. You can use the server and to check it and make the authentication for the user, and after that appropriate serve it for based on the granted privilege to use what the devices can use it. It's very important to understand that. Now let us move to the third paper, is a novel black wind optimization algorithm for the multi-level thresholding image segmentation. It's very important to understand the segmentation very well because segmentation is a critical step. in the image processing application, and everything, all application using the images, because and if we talk about the internet, we have a camera, so cameras need give out the video, give out the pictures, so we need to understand this kind of the of data as a picture or as a video. So one of the problem is the segmentation. This process separates the pixels of the image into multiple classes that permits the analysis of the object contained of the in that scene. Multi-level thresholding is the method that easily performs this task. The problem is to find the best set of thresholding that probably segment each images. Techniques are like also between the classes variance of the or Cooper entropy helps to find the best thresholding, but they are computationally expensive for more than 2 thresholding. Very important. So this paper give a solution to overcome such a problem to use of the novel heuristic algorithm called the black window optimization, BWO, to find the best thresholding configuration using the odds or the Cooper as an objective function to evaluate the performance and the effectiveness of the BWO based method. It has been considered the use of the variety of the benchmark images and compared against 6 well-known meta-heuristic algorithms, including the Gray-Wolf optimization. Now, let us move, because I think you don't have time to talk about it. So I need to go to the my paper. This is my paper. So as I said before, it's now under the investigation from the Mercedes car, the vehicle security system using a face recognition based on the Internet of Things. In recent years, as you know, the popularity of the automobile sector is increasing all over the world, and they are developed. But unfortunately, there exists an exponential increasing in the vehicles crime, because now I think all around the world, the economic, it's very bad and go down because what happened in the world from war the Ukraine and the Russia and between the Palestine and the Israel and what happened and the others. So the economic all around the world it's go down. That's why the people can maybe can go using the steal of the cars. So very important sectors to need to protect it as a scientist. Okay, so but there's the development of IT technologies and the many embedded mechanisms, the vehicle security system are continuously improving. So you need to know access rejection to the vehicle security system from the unauthorized person is a problem. We know that. But unfortunately, the actual problem is how to identify his face. This vehicle, the vehicle security system must employ the user authentication for access control using the biometric authentication based on the IoT in real time. So the surveillance of the surveillance system must keep the vehicle security by identifying the authorized driving via his mobile application and email in case of any unauthorized person or any intrusion trying to access the vehicle security system without increasing the complexity and without increasing the cost. Very important. So the solution is the proposed VSS IoT vehicle security system IoT system based on the face detection and recognition method for the vehicle security system through the interface of IoT technology with some sensors shielding based on the low power processor. So this system convert the image captured by using the USB camera installed in the vehicle to raise the scale images to detect them and recognize in real time. Where the combination of the AdaPost algorithm with the hard cascade classifier improve the face detection accuracy and employ the PCA algorithm to recognize driver face.
Excuse me, sir. I'm sorry to interrupt you, but we are getting a bit behind of time. So if you could please wrap up things faster, sir. Sorry, sir.
You talk with me. I am not stop share. You need me to stop share.
Yes, sir. Will you please repeat, sir, what you were saying? We were unable to hear you.
Okay, so is the time over or what? I don't know.
I'm so sorry to interrupt you, but another speaker is waiting in the meeting. So if you could please wrap up things faster, sir.
Is the time over?
Yes, sir. The time has already passed, and the other and the other speaker is actually waiting. So I'm sorry. I'm so sorry to interrupt you, sir.
Okay, just give me 2 minutes. You
All right,
just give me 2 minutes. I will finish my presentation.
All right.
Okay, 2 minutes. I will finish. Okay. Okay. Okay, I will move quickly on the proposed security system. It is so many main aim of the proposal is to detect and recognize the face of the professional thieves, provide a low cost, increasing the simplicity and user friendly and in the real time. Therefore, it must be identify the owner vehicle security, vehicle's driver first, and they provide him the authorization of his access to vehicle security as him. This is proposal of the systems containing or a combination of the biometric techniques, embedded devices, and beside that, we need to design the hardware and the software architecture. As you can see here, the basic flow chart of the entire vehicle security system of IoT. It's a well check, and if you have check the motion. If no, it will recheck again, and if yes, recognize the face, and if it's raised, it can open the motor, and if it's not recognized, it's internet check the internet availability and so on. And this is the hardware. What has happened? The devices used in my product. This is also the hardware architecture of the vehicle security system using the IoT. And this is we need to make an initialization and configuration of the our product. And this is the system initialization and the configuration. And also this is a design how to design the vehicle security system as a software by using the camera IP and so on. And we need to make some pre-processing phase, and after that we using the face detection, and after that using the face recognition, and after that we using the label phase for the detecting. As you can see here, it will detect the face and recognize our face here. And also using the mobile application email notification, and this is the application of the installed in the owner of the device of the car, and it will notify if something happened wrong for his car. And this is some implementation using the real data and using the ORL data sets. And this is some measurements of the to see the accuracy. And this is actually experimental results. And we tested this for the some for the five cars, for the five authorized drivers, where with 10 times with the classes and without, and we using the threshold, and this is some driver with the glasses and some driver with the without glasses and so on, and for all cars like this. And after that we make a comparison between some techniques, and our proposal to give the good sensitivity and the precision and the specificity, and also the comparison between the computer, if you use a computer, and the power and the low power processing. As you can see, our proposal give a good performance. And this is also the CPU utilized. So our propose using a good CPU utilized and the memory use. And this is a security, give you the good accuracy, and also for the price, we have a good price, like using the 80 dollars USD compared with the others. Okay, by conclusion, what I want to say from my presentation is to give us some ideas. And if we, as I can see here in the some students for the School of Engineering and the Computer Science. So if anyone want to communicate with me under the umbrella of the Scientific Innovation Research Group, so I'm here all the time, and I will be happy if you are connect with me. And by the end, I need to thanks all of you. I need to thank the president and the vice president and all organizers of the conference. I need to, this is my contact. If you want to contact, I'm here all the time. And the last, I need to thanks my my dear friend, Professor Agrawal. Thanks so much, Professor Agrawal. I don't know if she's here now or not. I'm not sure. But if it's not here, please, you can send her my greetings.
Yeah.
So
Yeah, thank you
thanks
so much, sir. Thank you. It was really
Thank you.
pleasure, and due to the time scarcity, we are not able to listen. But I saw the slides. You have done a tremendous work. Different performance metrics, PCA. I have just read technical terms. It's really a very good work. Matlab, student should listen. But sorry, actually, the another speaker in line. That's why, due to time scarcity, we are have unfortunate so that
No
we
problem.
are not able to listen. But the slides are really very good. Thank you so much, sir, for being with us. Thank you so much.
Thanks so much. And I'm here all the time, Prof. If your student want to connect with me, I'm here all the time. So thank you so much. And I'm also thanks for all the students to listening me. And I'm waiting all of you, all students, to connect with me. I hope for all of you the good day and the good conference as usual. Inshallah. Thanks so much. See you next time, inshallah. Thank you. Thank you,
Thank you,
bro.
sir.
Thank you. Bye.
Connect with chat. Chatting
Can I
karo.
start?
Yes, sir, you can start. Yes, sir. You are audible, you can start.
Okay. Good afternoon, everyone. My name is Álvaro Rocha. I came from Lisbon School of Economics and Management at University of Lisbon, Portugal. And I'm here to talk about a health data analytics maturity model for hospital information systems. A maturity model developed under a PhD process. Here I am to talk about it. Firstly, I will do a contextualization, then I will talk about growth stages theory and maturity models. Afterwards, I present a justification of a new hospital information system maturity model, its process of development, and at the end, I will present the hospital information system maturity model and the correspondent health data analytics maturity model. In the last 5 decades, maturity models have been introduced as reference frameworks for information systems management in organizations. In the healthcare domain, these models have also been used to address a wide variety of challenges and the high demand for hospital information systems. This increasing volume of data exceeds the ability of health organizations to process it for improving clinical and financial efficiencies and the quality of care. It is believed that careful and attentive use of data analytics in healthcare can transform data into knowledge that can improve patients' outcomes and operational efficiency. So, a maturity model in this conjecture is a way of identifying strengths and weaknesses of the hospital information systems maturity and thus find a way for improvement and evolution. This talk presents a proposal to measure hospital information system maturity regarding data analytics domain. The outcome is a maturity model which includes 6 stages of hospital information systems growth and maturity progression. Maturity models are based on the growth stages maturity or growth stages theory. This theory is based on the principle that people, organizations, functional areas, processes, etc., evolve towards enhanced maturity and following a development or growth process, which covers a number of different stages. A maturity model by this is its side are predicated patterns conceptualized in terms of stages. Typically, the stages are sequential and cumulative by nature, occur as a hierarchical progression that is not easily reversible, and involve a wider range of structures and human and organizational activities. Usually, a maturity model is a matrix, a table, composed by maturity stages and influencing factors of maturity. In the intersection of a maturity stage with influencing maturity factor, we have a set of characteristics or patterns which describe the characteristic of an entity for a specific stage of maturity and a specific maturity factor of influence of the maturity. So with a tool like this, it is possible to identify, to classify an organization, a department, an entity, what is its maturity model for a specific maturity influencing factor, and in this case with 6 maturity influencing factors and 4 stages, it is possible to have a specific organization in a different stages, taking into account the different influencing maturity factors according this schema present in this table. So we need and is the hard work identify based in studies that developed inside the organizations to characterize the evolution of the organizations through its life, and what you need when build a maturity model is to put the characteristics of evolution in the correct stages of maturity. Well, taking into account the hospital information systems domain, there are some maturity models developed and present by important institutions or entities around the world. And in this slide, I have one of them. It is the hospital IT maturity model from IDC, Health Industry Insights, a consultancy, just with influencing maturity factor, which is the type of applications or information systems or sub-information systems used in the hospital information systems. And as you can see, the things related with management of data in a perspective of data analytics, that characteristics appears in the last stage of maturity. It is the characteristic clinical data repository and data warehouse, a characteristic of the higher stage of maturity for this maturity model. Another important and credible maturity model is this one from the Healthcare Information and Management System Society. And like the preview, the characteristics related with data analytics appears again in the higher maturity stages. In this case, the characteristic is data analytics. Well, there are other maturity models in the hospital information systems field, but these two are very credible and from institutions well known around the world, and have been applied around the world to measure the maturity of the national information systems inside the hospital information systems, to compare the maturity between regions, between countries, and so on. Anyway, the maturity models developed until some times ago our healthcare maturity models were poorly, these healthcare maturity models were poorly detailed, failed to offer maturity assessment tools, and did not structure their maturity stage according to several influence factors. There is an absence of maturity models whose dimensions or influence factors are taken into account with different relative heights according to relevance. And in the case of adoption of a tool for assessing the maturity, not all had a properly systemized process to move to a higher maturity level. The identified models as a sufficiently broad scope covering all areas and subsystems of healthcare organizations. And because this, and in this sense, it seemed that a maturity model with holistic approach, including a comprehensive set of influencing factors, was missing. As consequence, we decided in a PhD process develop a more comprehensive, detailed, complete maturity model, focusing the hospital information systems. And here we have the activities carried out for the development of that new maturity model. Our work started with a literature review to identify the dimensions or the influencing factors of maturity for the new model. 12 dimensions were identified, and the next step was a survey, an application of a questionnaire to a large set of experts, 144 experts. The experts were people who worked in information systems directly or indirectly inside healthcare institutions. We got 46 full answers, 46 questionnaires completely answered, and based on the results, we define only 6 dimensions of maturity for the new model, because from the initial 12, some of them were considered important, and some of them was rearranged, and the result, as I told you before, was 6 influencing maturity factors or dimensions for the new model. We compose the maturity model filling the cells corresponding to the intersection of maturity states and influencing maturity factors. Present a first version of our model with 6 maturity factors or 6 influencing maturity factors and 6 stages. And the next step was the validation of our proposed model by the best 5 CIOs, Portuguese CIOs, from a private hospital for public hospitals, but in this case, all with different size. They validate with our support the model. They propose the election of some characteristics, they propose the addition of some new characteristics, and they propose the dislocation or the movement of some characteristics from one stage to a different stage of maturity. And with this process, we got a final maturity model, the main result and the main contribution of the PhD process. Our maturity model is composed, as I told you before, by 6 stages of maturity, from advocacy to integrated relationships, and 6 influencing maturity factors, from the more important to the less important, and the more important is, in fact, data analysis or data analytics. This is the main dimensions to evaluate nowadays the maturity of an hospital and the maturity of the correspondent hospital information systems. Data analysis is the more important factor. Then the factor strategy, then people, afterwards electronic medical record, then information security, and the last one, systems and infrastructure. This is the first maturity model around the world which has influencing maturity factor designated by data analysis. Is the first one, the first model which show that data analysis is the main dimension to evaluate the maturity of an hospital information systems. The model is composed by these characteristics for the first 3 influencing maturity model or dimensions. This is the main result of our maturity model. As you can see, a table, traditional or a classic table for a maturity model with maturity stage on top. On left, the maturity dimensions. And okay, the second part of our maturity model. And taking into account our comprehensive maturity model to manage the hospital information systems, taking into account its progression, its evolution through its life, you can derive a specific maturity model focused only in data analytics from the dimension data analysis, and the result it's hospital information system maturity model for data analytics with the same maturity stages and with well visible the characteristics or the patterns of evolution of the maturity for data analytics from the stage advocacy with characteristics like isolated and fragmented data analysis solutions, heavy and complex production of internal and external experts, data integrity ensures inability to handle large volumes of variety of data, problems when collecting data from different systems, lack of analytical and IT resource, and use of spreadsheets and local database. This is the lower maturity stage, and the higher maturity stage or more advanced maturity stage integrated relationship, we have characteristics like adoption of personalized medicine and prospective analysis, patient care adjustment based on population result and genetic data. All valuable data are available for analysis and exploration. Real-time data are used in critical activities such as patient care. The penultimate internal and external data serves to improve and optimize cost and quality. And the last one, permanent data analysis, mentally and culture. So this is our maturity model. We have an algorithm to apply this maturity model to determine, to compute the maturity stage. In this case, only for data analytics dimension, but we have an algorithm to determine the maturity stage for the 6 different influencing maturity factors. For example, an hospital can be in different stages of maturity, considering different maturity influencing factors. Our work was published in top leading journals in the information science and information fields area. We published in the best journal around the world in the information science and information systems field. This is the International Journal and Information Management. We published the maturity model to data analytics maturity factor, and the comprehensive and the broader model for hospital information systems, published in a new leading journal, first quartile, the Journal of Business Research. Our work was published in other GCR journals, and also a book was published, but in Portuguese. And our model, it's a well-known model applied in several hospitals around the world, and also adopted by several schools of health in Portugal and other countries. Because this, we are very honored by its positive impact. So right now, I would like to thank your attention, and it is time for questions and answers. Thank you very much for your attention.
Thank you so much, sir. Thank you so much. Is there any queries, any questions? No? Okay. Yes, please welcome.
May I invite Assistant Professor Dr. Panchi Gupta, MIT University, Noida, Uttar Pradesh, to present a moment.
Please increase the volume because I'm not hearing the question.
Check the volume, check.
So, like, it's okay from our end, please try and
Yes, Aditi, you.
So may I invite Assistant Professor Dr. Panchi Gupta, MIT University, Noida, Uttar Pradesh, to present a memento to our esteemed speaker, University of Lisbon, Portugal.
I don't hearing you. You must increase the volume or speech a little bit higher.
Yes, sir. Is it audible now?
Yes,
Hello?
now I'm hearing you.
Okay, yes.
Okay, let's go.
Yours now. So can you hear us now?
Yes.
Okay. So with this, we conclude the session. We hope that it was an enriching and informative experience. I once again, on the behalf of fraternity of MIT University, Uttar Pradesh, thank all the guests and dignitaries for their significant presence. We would also like to thank the students for their cooperation.